Okay, so this is lesson part number 2. So in that case, we're looking at question number 48 on the same handout. It's one at the bottom here, the one with the crankshaft. The question reads, on a certain automobile, the crankshaft is 3 inches long. Okay, that's this part of the thing, 3 inches long. And the connecting rod is 9 inches. So this part is 9 inches. At the time when OPQ is 15 degrees, so in that case, okay, this is the diagram that they provide. OPQ, so this angle is 15 degrees. How far is the piston from the center? So in that case, if you want to figure out what this blue line is, what the distance is. Okay, the reason why I drew these three is what I want you to realize is what a crankshaft works, or how it works. So in that case, the blue part of this on the crankshaft here, that is not present. Okay, the only thing that's present is the piston, the part where it's connected to the circle, and the center. So this black line here is where the crankshaft is actually, how it actually works. Okay, so this thing will spin, and this distance will drive this piston back and forth, back and forth. So this, as this spins, piston's going to be back and forth. So with this question that we have in front of here, the information we've been provided is side, side angle. So for this example, it's going to be a side, side angle triangle. Okay, so for this question, you might end up with 0 triangles, 1 triangle, or 2 triangles. For this question, I'm guessing it's going to be probably at least 1 or 2. Okay, so let's go ahead and set this relationship up. So in that case, they have the diagram we've already set up as a triangle, and then let's go ahead and write the relationship. So in that case, sine of, in this case, 15 degrees divided by opposite, which is 3, is equal to sine of, okay, so you have P and Q. These ones are very, you might mess them up because they look like 0s and 9s. So let's go ahead and change this to B and call this one C. Okay, so sine of B, in this case, we don't know. Or in this case, B. Okay, and equals sine of C. We have this. Okay, and then the relationship that we have here is B. Opposite of B is, we're trying to figure this one out. So this is B, and then C is equal to 9 inches. Okay, so now we have the stuff we need to figure out. We need to figure out what angle B and C are equal to. So in this case, we need to figure out what this is. The blue line for this problem here is what we're looking for. So this is the question mark. This is OP. They want to figure out what OP is. Okay, so for this question here, step number 1 is to draw the diagram and the relationship. So step number 2, we're going to figure out what, let's figure out what C is. Okay, because for this ratio, we can also find an angle C. In that case, this is step number 1. Step number 2 here, we have sine of C is equal to, move this up and this one over, you have, oh, just this one up, 9 sine of 15 degrees divided by 3. So this comes out, in this case, if you put in your calculator, 9 sine of 15 divided by 3 is a number less than 1. So in that case, in this situation, this triangle, this angle would actually exist. So in that case, in this case, C is equal to arc sine of, in this case, simplified, 3 sine of 15 degrees. This comes out, this gives us an answer. This one is equal to 50.937. 937 degrees. 937, okay? That's the angle. So in that case, this is C1. So the other one here is figure out what the other angle is. So C2 here is equal to 180 minus 50.937. In that case, if you put in your calculator, 180 minus C1, this gives us 129.063 degrees. Okay, so those are your 2 triangles. Okay, so step number 3, we've got to figure out how many triangles we have. So in that case, in this case, A plus C2 will be the one that we have to test. A plus C2 is equal to 100, or in this case, it's going to equal to 50 plus, is it 15 degrees plus 129.06 degrees. You put in your calculator, this number is less than 180. Okay, so since it's less than 180 degrees, you have 2 triangles. Okay, the first triangle is going to be 15 plus 50.937 and whatever angle you get for B. Okay, so B1. So in that case, step number 3, step number 4, we're going to figure it out. So triangle number 1 here, we're going to have, this is very important. So in that case, triangle number 1, we have, would be, let's relate the relationship. So sine of 15 degrees over 3 is equal to sine of 50.937 degrees divided by 9 is equal to sine of b in this case. So sine of b1, we have to go figure that out, and that divided by, in this case, b. Okay, so in this case, b1 here is equal to 180 minus 15 minus 50, 0.937. So this one comes out as 114.063 degrees. Okay? So that's what we have for B1. Now, to solve for B in this situation, B is equal to, rearrange, move, let's just move this one, B, this relationship with this relationship. So in that case, we have B is equal to, move the 3 up, so you have 3 sine of 114.063 divided by sine of 15. Okay, this answer comes out as, so this is B1. B1 is equal to 10.584. 10.584 inches. Because that's the distance. Okay, so the next example we're going to do, next part of this is to figure out what triangle number 1. So in this case, triangle number 1. Okay, now next part is triangle number 2. Okay, so triangle number 2. So in that case, we end up having, again, write the relationship. So sine of 15 degrees divided by 3 is equal to sine of the other angle, 129.063 degrees divided by, in this case, 9 is equal to sine of B2 divided by B2. So putting everything together here, we can find the angle B2 is equal to 180 minus 15 degrees minus 129.063 degrees. This comes out as, in this case, we get 35.937. 35.937 degrees. Okay? So that means by rearranging now, we have to solve what B2 is. So in this case, B2 is equal to, so in that case, let's use this comparison. So move the B2 up, move 3 over. So you have 3 sine of B2, which is 35.937 degrees divided by sine of 15 degrees. So this comes out as 6.803. Okay, so in that case, what we need to look for is this distance. So this is opposite of B. So we have found that it could be ending up with 10.583 inches or 6.803 inches. So those are the two situations we might end up with. So for this question, you don't have to go ahead, you don't have to proceed forward and say the angles and the ratio and the legs for triangle 1 and triangle 2. So all you have to do is answer the question, because the question asks what is the distance between O and P. In this case, it's right across B. So in that case, so your situations you end up with, case number 1, you have 10.584 inches, and case number 2, you have 6.803 inches. So those are the two scenarios for this problem. So in this case, we are done with this question. Okay, make sure you go with 3 decimal places and state your type of triangle and draw your triangle and proceed forward and figure everything out. Okay, so make use of what you learned yesterday of the law of sines with the ambiguous case. So it's the SSA case, and that's it. Okay, so I will check out I'll assign you the questions in a little bit. Okay, so that's all we have today. Okay.